is Aditya, and I work with Frappe Technologies. I mostly work on infrastructure tooling. So on this slide, I'm about to take you on a journey about the changes that we have made, the major changes that we have made on our production environment. So you cannot start talking about production environment without the standard deployment. So this is the stuff that you get when you start with the easy install script, right? You say screw Frappe, I'm going to host my own installation. So basically, this is what the standard deployment is. You start with a single server. You get the concept called bench. The bench runs few processes: the Gnicon process, where we serve web request; the RQ process, where we do job execution; socket.io, real-time communication, and then we use Redis for caching and queuing, supporting socket.io, right? And then we have our own multi-tenancy model called sites. So let's just say for this example, we are using two sites, .org and frappe.io, right? Then we actually throw Nginx on top of it as a web server, and we use MariaDB as our standard RDBMS server, right? So it's the standard deployment. Certain problems with standard deployment, obviously. So when either of these services fail, that means downtime. When you want to actually do migrations on your site, that means downtime. When you want to scale your server up or down, that means taking the whole server down, either using an entirely new server or using AWS or something else to scale up your server. But again, means downtime, right? So Frappe faced this problem a long time ago, and Frappe did what it does best. It threw an engineer at this problem and solved this problem. So the way Frappe solved this problem is by coming up with something called as Central, right? Now let's see what Central is. Essentially, again, you start with the standard deployment server. Let's just focus on the important details here. Let's just get rid of the processes. And what we do essentially is create a copy of this standard deployment. And we make sure that this copy, the secondary copy, we call it replica, is actually synced with the primary server all the time. We do the syncing by MariaDB replication and rsync. We throw an Nginx proxy on top of it so that we can actually switch from primary to secondary whenever we want to. That is at the core of Frappe Central, right? Again, now the question is, how do you scale this? So what we do is, again, let's just get rid of some of the details. Let's just name these servers. So we call them proxy, master, and replica. And every time we want to add capacity to the system, what we do is we create a new setup server, a new pair. We install the new site on this pair, and we are done. So far, this has worked for us for, say, last 5 years. We are serving right now 13 pairs of servers. Now, these are huge servers serving almost like running almost 96 gigabytes of RAM and 12 cores of CPU. And we are serving almost 3,000 sites. So far, everything is good. Again, on Central, you get replicated deployment. So you don't have to worry about service failures. You also get side-by-side migrations, so you don't have to worry about other people's site being migrated. So reduce downtime. And you don't have to worry about the growing cloud. So as long as sites keep on coming, we can just keep on throwing more servers at the infrastructure, and everything works really, really well. And then we wrote a small feature called auto-deploy. So auto-deploy is this small part that essentially handles our own deployments without any human intervention. So essentially, when Naveen lets a bug through, auto-deploy makes sure that you get it as soon as possible. But again, Central is not really, really ideal. You get two problems. If obviously new sites keep on coming, then Central handles it really, really well. But if an existing site starts growing, there is no way to instantly allocate a new resource to this site. Essentially, we have to take it down, allocate a new replica or a new pair to this site. So we have done this in the past. And if, let's just say, for some reason, one server starts demanding more resources, the other 12 servers, or other 24 servers for that matter, cannot help this server, right? So load sharing is really a problem. So again, Frappe says, okay, how do you solve this problem? They throw an engineer at this problem and say, okay, do something. So this engineer, again, then comes up with a new system for orchestration. By the way, like, there are tons of ways of solving this problem. And if you have your own opinion, right, get your own talk like Elastic did. So by the way, that engineer again likes to talk about himself in third person. So the way we solve this problem is we take the standard deployment and we say, okay, let's just not worry about the abstractions. Okay, so let's just focus only about the processes and only the sites. Now keep this at the back of your mind for a moment. We'll go back to the central architecture, right? The thing that we saw just now. Let's just get rid of the replicas for a moment, for the sake of simplicity, and use the small model that we actually used as a server, right? Now, and then again, a little bit of cleanup. This is what you have at the core of Central, right? We haven't made any changes yet. So actually, to get to backbone, right, what you have to do is actually throw away MariaDB servers. I mean, essentially remove MariaDB processes from each of these masters to a single server. So we do that. We can do the same about Redis, and we can do the same about Socket.io, right? So for Socket, we get less cluttered system. But again, at the core of the problem that we saw about with Central is essentially that the sites are tied to a single server. And again, the servers are tied to some setup sites. So to solve that problem, right, this engineer says, okay, let's just throw the sites onto a remote storage system, right? So what we can do actually is now mount the remote storage whenever we want, wherever we want, right? So what we are left with is this two servers that look exactly identical, right? Now again, let's just get rid of them. Let's just use only one server for representing this diagram. To do this remote storage system, what we use is called, the service we use is called Ceph. So now again, let's just use Ceph instead of the complicated size diagram. And the complicated piece of machinery, we are left with the Nginx, Unicorn, and RQ set. We call that a Frappe service, right? A little bit of cleanup, and bam, you got yourself backbone. This is what exactly is at the core of backbone architecture, right? Now you see, essentially, like there's nothing really different that we have done than the standard architecture. Like there are a couple of things that are essentially at the core of this. And this is the important one, the decoupled, right? What you have done is essentially said, okay, instead of storing the sites on each of the servers, let's just store them somewhere else so that we can spawn, essentially making the server stateless. We can spawn them whenever we want, wherever we want. So we use Ceph, and Ceph lets us export a file system called CephFs over remote. So Zero Dash solved the same problem using S3. So we didn't want to do that, right? We didn't want to change any of our infrastructure. Essentially, our users don't see any difference between the current standard bench production, the standard central architecture, and backbone, right? So what we do is essentially we have Dockerized our workers. So the thing is actually we just use Docker as a process manager and a packaging system. We're perfectly happy with supervisor. It's just the packaging that we were worried about. So because of these changes, we have to do some more changes to our deployment process, right? So the Canary deployment is the idea where you do side-by-side migrations. You don't throw all of your customers to a new version entirely. You do that one by one. So in case the new version is faulty, you can fall back to the one that was working. So that's not really true in case of the pull deploys that happen on Central. So right now, because of the backbone architecture, everyone, no matter what kind of deploy is happening, has to go to this Canary deployment. So like not all of the people get that Navin just released. So that is something that looks like a problem, but actually is a solution. And then the second problem that second change that we do is now we build the images that actually run Python processes somewhere else. We create this environment at once and deploy it on our servers. We do the same with our static assets. Because in Center, if we release multiple times a day, we have to actually waste so much time installing Frappe dependencies and yarn dependencies, and then building the static assets. So, but at the core of this, right, is the important feature that we really wanted. We didn't care about anything else. We didn't care about Docker. We didn't care about the decoupled storage, right? What we wanted to solve was this dynamic scaling problem, right? What do we do when one of the sites starts growing? Not instantly. We don't want to worry about what happens this moment, right? But if we see one of our customers, let's just say in this case .com, ERPNext.com starts growing continuously, not a burst usage. how do we solve that problem, right? In our other case, we had to throw them to a entirely new server, and that was expensive. That meant more cost for ERPNext.com hosting, and that meant extra resources, right? Because we need to do DevOps on that machine as well. So let's see how exactly Backbone solves this problem, right? So we come back to Backbone architecture. So this lets us add actually Frappe workers as you want, as many as you want. And you can also remove Frappe workers if you think your load has gone down, right? And it's just not Frappe. The Ceph storage system we have used also allows you to do the same. So if you, let's just say, need more storage, you can add just more Ceph nodes. If your reads or writes requirement increases, you can just add more nodes, or even like in case of reduction, you can remove these nodes. And always, like as always, you can do all, like no one is stopping you from doing that. And also, like, for instance, sometimes the background job processing can actually require more machines than the web request processing. So you can do that as well. You can actually say, okay, let's just spawn more workers just to do background job processing. And you can actually make them switch. So doing jobs, now they can serve web requests as you want them to. So you can do all of this using Backbone CLI, which is really identical to Bench CLI. And then to actually control our service, we install a Flask-based, essentially a Flask app that exposes a REST endpoint, and we just issue commands over this REST endpoints. We don't use Ansible, and we certainly don't use any other complicated command issuing system. And again, this is good enough for us. We are right now serving, say, almost 30 servers on our cloud, and this sort of architecture is good enough for us. So that is basically what is Backbone, right? But again, like everybody's talking about Kubernetes, right? And we also wanted to do Kubernetes. We were faced with this problem. And then we saw under the hood of Kubernetes and saw the 5 million lines of monstrosity that it is. The actual bloatware, the unnecessary bloatware that it is, right? And by the way, like, let me tell you, ERPNext is just 1.2 million lines of code, the entire ERPNext subsystem. Now, and then there are like tons of unnecessary pieces that Kubernetes actually gives you that you don't necessarily need. One of these is Kubernetes networking. So Google launches billions of containers every single week. They need Kubernetes, and they have built Kubernetes. We launch 30 servers, not every year, not every month, like 30 servers in total. We don't really need this powerful networking, and you don't need it either. The Kubernetes scheduler is essentially the component that decides which process runs on which server. And again, these are crazy people running containers inside VMs, inside containers. We didn't even use containers right now. We just moved to them, and we wouldn't even use them if we could use any other packaging system. The Kubernetes API server is, again, totally useless piece of software. This is literally the last piece of feature we need. We don't want our API server to be highly scalable. And again, the Kubernetes components are totally like over-engineered. Again, I'm not saying that Kubernetes is actually totally useless piece of software. What we are saying is, if you're running at any scale close to us, right? We are serving currently almost 25 terabytes of memory. That is our total memory usage. Not even 25 terabytes, actually, even much less than that, 2.5 terabytes RAM usage. That is our server capacity. And if your capacity is anywhere close to that, even less than that, right, you don't even need any of the stuff that I've just mentioned. If you start growing, then yeah, you're going to need something like Backbone, but certainly not something like Kubernetes. Now, obviously, you can go ahead and use whatever the hell you want. You can install whatever crap Google throws at you on your server. But we choose not to. And again, we are not against bloatware. Obviously, we make one. Right? So that's basically my presentation. And again, there's nothing that actually is totally essential, crucial. There's nothing that Backbone provides that is crucial to our business, right? So we're planning to release it to open source. So we're actually trying to make this as a standard replacement for Bench. So if you want to do a single server deployment, you can use Bench. But if your requirements goes more than this, then you can use Backbone. So that's basically it. Thank you.